The morning sun over the Tunisian desert turned the sand into waves of amber heat as Oberfeldwebel Klaus Richter crouched behind the sloped armor of his SdKfz 222 armored car. The metal was already hot to the touch, though it was barely 700 hours. He'd been with the Reconnaissance battalion for 18 months, and the half-inch steel plating surrounding him had become as familiar as his own skin. It was March of 1943, and the Afrika Korps was learning hard lessons about American firepower. Richter's crew had laughed when they first heard reports from the front about American machine guns. The German MG 34 and 42 were legendary for their rate of fire and accuracy, mechanical masterpieces that could shred infantry at 800 meters. When intelligence briefings mentioned that the Americans relied heavily on a machine gun firing half-inch caliber ammunition, the reaction in the crew compartment had been dismissive. Half an inch. That was anti-aircraft caliber, far too large and heavy to be effective against ground troops. The Americans, it seemed, had confused raw size with battlefield utility. The SdKfz 222 was designed for exactly this kind of asymmetric engagement. Its 8mm armor plating on the sides and 14mm on the front was more than sufficient to stop rifle fire and machine gun rounds. Richter had seen 7.92mm bullets from British rifles spark harmlessly off the hull dozens of times. The vehicle's 20mm cannon gave it teeth against soft targets, and its speed, nearly 80 km per hour on good roads, made it ideal for reconnaissance and harassment. The crew of 4 felt reasonably secure behind their steel cocoon. That sense of security lasted until the first burst of American fire found them. They'd been probing American positions south of Kasserine Pass, part of a reconnaissance screen meant to identify weak points, in the Allied line. The Americans had been in theatre for less than 3 months, still learning the basics of desert warfare. German tactical doctrine assumed these green troops would break under pressure, just as French colonial units had done 2 years earlier. Richter's commander, Lieutenant Vogel, had been particularly confident during the morning briefing. Find the Americans, observe their positions, and withdraw before they could organize effective resistance. The first indication that something was different came from the sound. German machine guns produced a distinctive tearing cloth noise, a mechanical scream of rapid fire. The British Bren and Vickers had their own acoustic signatures, slower and more methodical. But this sound was entirely new, a heavy, rhythmic pounding that seemed to come from everywhere at once. Thump, 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 a mechanical hammer striking an anvil at 550 rounds per minute. Richter's driver, Gefreiter Hans Müller, pulled the armoured car into a shallow wadi for cover, standard procedure when encountering unexpected fire. The vehicle's thin armour was proof against small arms, but caution was always prudent. Vogel raised his binoculars, scanning the low ridgeline 400 metres ahead where the firing originated. Through the heat shimmer, Richter could see the distinctive shape of an American half-track, its angular profile unmistakable even at this distance. Machine gun position, Vogel announced calmly. Heavy caliber by the sound, probably their half-inch weapon. We'll circle to the north and engage with the cannon. The plan was sound. The 20mm autocannon outranged any machine gun, and the armour would protect them during the approach. Müller gunned the engine, and the SdKfz 222 surged forward, its wheels biting into the packed sand. They'd covered perhaps 50 meters when the first round struck. The sound was unlike anything Richter had experienced. Not the ping of rifle, bullets, or the clang of machine gun fire, but a series of tremendous metallic impacts that rang through the entire hull like a gong. The vehicle shuddered with each hit, and Richter saw something that made his blood turn cold. Sunlight was streaming through a hole in the rear armor plate. An actual hole, perfectly round, about the diameter of a man's thumb. "We're penetrated!" he shouted, his voice cracking with disbelief. Another burst struck the vehicle's flank. This time, Richter watched in horrified fascination as a half-inch projectile punched through the 8mm side armor, crossed the fighting compartment mere centimeters above his head, and exited through the opposite side, in a spray of metal fragments. The interior of the armoured car, which moments before had felt like a protective shell, suddenly seemed as substantial as paper. Müller needed no orders. He threw the vehicle into a hard turn, presenting the frontal armor to the American position, while simultaneously backing into the cover of the Wadi. More rounds struck the glacis plate, the heaviest armor on the vehicle at 14 millimeters. 2 penetrated. 1 round struck the engine housing and must have damaged something critical because the motor began running rough, belching black smoke. Vogel was screaming into the radio, his earlier confidence evaporated. "This is Lux 3, taking fire from American heavy machine gun. Armor penetration at 400 meters. Say again, armor penetration. Requesting immediate support." The response from battalion was incredulous. Machine guns didn't penetrate armor, not at 400 meters, not through 14 millimeters of steel plate. The radio operator demanded confirmation, as if Vogel was confused or panicking, but there was no confusion. Richter counted 7 holes in the vehicle's armor, 7 impossible wounds that shouldn't exist. They withdrew under smoke, the damaged engine protesting every meter. Behind them, the American machine gun continued its methodical pounding, each burst a reminder that German assumptions about battlefield weapons had just been violently revised. The crew rode in silence, each man alone with the realization that the protection they'd trusted was inadequate against weapons they'd dismissed as oversized and impractical. Back at the battalion assembly area, other crews gathered around Richter's SdKfz 222 to examine the damage. The holes spoke for themselves, but what shocked the assembled soldiers was the angle of penetration. These weren't glancing blows or lucky shots hitting weak points. These were direct penetrations through armor plate at ranges where machine gun fire should have been nothing more than an annoyance. Word spread quickly through the Reconnaissance battalion. The Americans had a machine gun that could kill light armor. That evening, Richter sat with his crew and tried to process what had happened. They'd all seen the propaganda films showing German technical superiority, the newsreels celebrating the panzer divisions and the precision engineering of Wehrmacht equipment. The idea that American industry, known for mass production rather than quality, could produce a machine gun capable of defeating armor seemed to contradict everything they'd been told about the respective capabilities of the two nations. The intelligence briefings that followed over the next several days painted a disturbing picture. The American M2 Browning machine gun, firing 12.7mm ammunition, wasn't just an oversized anti-personnel weapon. It was specifically designed with armor penetration in mind. The standard ball ammunition could punch through quarter-inch steel plate at 500 meters. The armor-piercing variant, which used a hardened steel core, could penetrate up to 25 millimeters of armor at close range and 14 to 16 millimeters at 400 to 500 meters. German engineers had known about the weapon's existence since the First World War, but they'd fundamentally misunderstood its purpose. European military thinking classified machine guns by their anti-personnel role. Heavy machine guns like the German MG-34 were designed to deliver sustained fire against infantry formations. The idea of a machine gun as an anti-materiel weapon capable of engaging light vehicles, aircraft, and fortifications hadn't translated into German tactical doctrine. The numbers were damning. An SdKfz 222, with its 8mm side armor, could be penetrated by M2 fire at ranges exceeding 600 meters. The SdKfz 231 series, the 6-wheeled armored cars that formed the backbone of German reconnaissance, had 10 millimeters of armor on the hull, vulnerable at 400 meters. Even the Panzer II, a light tank with 14 millimeters of side armor, could be defeated by sustained M2 fire at combat ranges. What made the situation worse was the ubiquity of the weapon. American forces mounted M2 Brownings on virtually everything: half-tracks, jeeps, trucks, tanks, and fixed positions. A single American infantry company might have 4 to 6 M2s in its weapons platoon. An armored division could field hundreds. German reconnaissance units, accustomed to operating with relative impunity behind enemy lines, suddenly found themselves vulnerable to what they'd previously considered defensive weapons. Richter's crew received a replacement SdKfz 222 within a week. This one had been modified in the field with additional armor plates welded to the sides and front, adding another 6 mm of protection. The improvised armor brought the total thickness to 14 mm on the sides and 20 on the front. It also added nearly 300 kilograms to the vehicle's weight, reducing its top speed and acceleration. The modifications were better than nothing, but everyone knew they were inadequate. 20 mm of armor might stop M2 ball ammunition at longer ranges, but armor-piercing rounds would still penetrate at typical engagement distances. The psychological impact of this vulnerability was profound. German armored reconnaissance had always relied on speed and surprise, operating on the principle that light armor was sufficient protection against the weapons they'd encounter. The SdKfz vehicles weren't designed to slug it out with enemy armor. They were designed to scout, observe, and withdraw before heavy weapons could engage. But the M2 Browning changed that calculus. A weapon that could be mounted on a jeep and carried by infantry support units made every engagement potentially lethal. Richter noticed the change in how his crew operated. Where before they'd approached American positions with calculated aggression, now they maintained much greater standoff distances. The 20 mm cannon on their vehicle outranged the M2, but only barely, and engaging American positions meant exposing themselves to return fire that could prove fatal. The reconnaissance battalion's mission effectiveness declined noticeably. Scouts who feared to scout, who hesitated to close with the enemy, provided less useful intelligence. The problem extended beyond reconnaissance vehicles. German half-tracks, the workhorses of mechanized infantry, were even more vulnerable. The SdKfz 251 series that transported Panzer Grenadiers into battle had 8 mm of armor on the sides and 14.5 mm on the front plate. Against rifle fire and shell fragments, this was adequate protection. Against M2 fire, it was tissue paper. Infantry riding in half-tracks learned to dismount much farther from enemy positions, reducing the vehicle's utility as assault platforms. American forces quickly recognized the M2's effectiveness against German light armor and adapted their tactics accordingly. Rather than using the weapons primarily in anti-aircraft roles, they began positioning them as anti-vehicle weapons along likely German approach routes. A well-placed M2 position could interdict an entire sector, forcing German reconnaissance to detour or risk destruction. The weapon's relatively flat trajectory and long effective range made it ideal for this role. By April of 1943, German tactical directives explicitly warned about the threat posed by American heavy machine guns. One captured document, later analyzed by U.S. Army intelligence, stated, American 12.7 mm machine guns must be considered anti-tank weapons capable of defeating light armored vehicles at ranges up to 500 meters. All reconnaissance and support vehicles should maintain maximum possible standoff distance and avoid direct engagement. The directive represented a remarkable shift in German thinking. A machine gun, a weapon traditionally relegated to infantry support roles, was being classified alongside anti-tank rifles and light cannons as a threat to armored vehicles. For soldiers like Richter, who'd spent months believing their armor made them invulnerable to anything short of artillery or dedicated anti-tank weapons, the adjustment was both tactical and psychological. The material reality of the M2's effectiveness revealed uncomfortable truths about the industrial competition between Germany and the United States. German engineering had focused on precision manufacturing and technical sophistication. The MG 34 and 42 were masterpieces of machine gun design, with tolerances measured in hundredths of a millimeter and manufacturing processes that required skilled labor. But they fired a standard rifle caliber cartridge, the 7.92 x 57 mm round, that was optimized for anti-personnel use. The American approach was different. The M2 Browning, designed by John Browning in 1918 and refined throughout the interwar period, was built around the 12.7 mm cartridge from the beginning. This round, initially developed for anti-aircraft use, delivered tremendous kinetic energy, approximately 18,000 joules at the muzzle, compared to roughly 3,800 joules for the German 7.92mm round. The difference wasn't subtle, it was a fundamental reimagining of what a machine gun could accomplish. American industry produced M2 Brownings at a staggering rate. By war's end, the United States would manufacture over 2 million of these weapons. They were mounted on everything from PT boats to B-17 bombers, from tank destroyer turrets to stationary fortifications. The manufacturing process, while requiring precision, was designed for mass production rather than artisan craftsmanship. Parts were interchangeable between weapons, maintenance was straightforward, and the basic design proved so robust that M2S would remain in service decades after the war ended. German forces in North Africa and later in Italy found themselves constantly engaged by M2 fire. The weapon's psychological effect was perhaps as significant as its material impact. Soldiers who'd been trained to think of machine guns as area weapons, tools for suppressing infantry, now had to treat them as precision anti-vehicle threats. Every jeep carrying an M2 became a potential ambush point. Every American defensive position might hide weapons capable of destroying light armor at ranges previously considered safe. The German response involved both tactical and material adaptations. Additional armor was added to reconnaissance vehicles wherever possible, though this always came at the cost of mobility. Crews were trained to identify M2 positions by their distinctive sound and muzzle flash characteristics. Engagement protocols were revised to emphasize standoff attacks using vehicle-mounted cannons rather than close reconnaissance. Some units began requesting infantry support for any mission that might involve contact with American forces, using foot soldiers to suppress M2 positions before vehicles advanced. But these adaptations couldn't fully compensate for the fundamental vulnerability. The SdKfz 222, 231, and other light armored vehicles had been designed in an era when machine gun fire meant 7 to 8mm rifle caliber bullets. They simply couldn't be up-armored sufficiently to defeat 12.7mm armor-piercing ammunition without becoming too heavy to fulfill their reconnaissance role. The choice was between mobility and protection, and neither option was satisfactory. Richter's crew survived the North African campaign and was later redeployed to Italy after the Axis collapse in Tunisia. There, they encountered the M2 again, now in even greater numbers as American production ramped up and more units were equipped with the weapon. The Italian terrain, with its narrow roads and limited sight lines, made the vulnerability even more acute. German reconnaissance vehicles that ventured too close to American positions were systematically destroyed by heavy machine gun fire. By 1944, the lessons learned in North Africa had been incorporated into German training and doctrine throughout the Wehrmacht. New crews were warned explicitly about the American 12.7mm machine gun and its capability against light armor. Veterans like Richter passed along their knowledge: maintain distance, never assume your armor will protect you, and treat any American position as potentially lethal to light vehicles. The irony of the situation wasn't lost on German soldiers who'd spent years being told about Teutonic engineering superiority. Here was an American weapon, designed 25 years earlier, that had been consistently underestimated by German intelligence and was now forcing wholesale tactical revisions. The M2 Browning wasn't more sophisticated than German weapons. It was simply designed for a different purpose and manufactured with the kind of industrial capacity that Germany couldn't match. The production numbers told their own story. Germany manufactured approximately 400,000 MG 34 and 42 machine guns during the entire war. Impressive by any standard, but dwarfed by American output, the United States produced those 2 million M2 Brownings, along with millions of other weapons, while simultaneously building ships, aircraft, tanks, and vehicles in quantities that staggered German planners. The half-inch machine gun that penetrated armor at 500 yards wasn't just a weapon, it was a symbol of industrial might that no amount of tactical sophistication could overcome. Richter survived the war, though his SdKfz 222 did not. In post-war interviews, he spoke about the moment when American bullets first punched through his vehicle's armor, describing it as the day he realized that German invincibility was a myth. The technical specifications, the penetration data, the tactical adaptations, all of these were important. But the real lesson was psychological. American industry could produce weapons in quantities and qualities that German manufacturing couldn't hope to match. The M2 Browning remained in service with U.S. forces for decades after World War II, seeing action in Korea, Vietnam, and conflicts into the 21st century. Its basic design, created in the aftermath of World War I, proved so effective that it outlasted virtually every other weapon system of its era. German soldiers who'd laughed at the idea of a half-inch machine gun being a serious battlefield threat learned to respect its capabilities the hard way, through perforated armor and shattered assumptions. The story of the M2 versus German light armor encapsulates a larger truth about the Second World War. Technological sophistication alone couldn't overcome industrial capacity. Germany produced brilliant engineers and precision weapons, but the United States produced functional weapons in overwhelming numbers. The 12.7mm machine gun wasn't exotic or complicated. It was simply effective, reliable, and everywhere. For soldiers like Richter, crouched behind armor that no longer felt protective, that ubiquity was the most terrifying thing of all. The technical specifications of the M2 Browning revealed why German assumptions had been so catastrophically wrong. The weapon fired the 12.7 by 99mm cartridge, developed by Winchester in 1918 specifically to defeat aircraft armor and machinery. The standard ball round, designated M2, used a full metal jacket bullet weighing between 43 and 45 grams. When fired from the M2 Browning's 45-inch barrel, this projectile left the muzzle at approximately 900 meters per second, delivering over 18,000 joules of kinetic energy. But it was the armor-piercing variant, the M2AP round, that made the weapon lethal to German light armor. This cartridge used a hardened steel core surrounded by a gilding metal jacket. The core's heat treatment and metallurgical composition gave it extraordinary penetrating power. U.S. Army Aberdeen Proving Ground tests, conducted in 1941 and documented in Ordnance Department technical manuals, demonstrated that M2AP ammunition could penetrate 25 millimeters of rolled homogeneous armor at 200 meters, 20 millimeters at 400 meters, and 14 to 16 millimeters at 600 meters. These numbers had devastating implications for German armored reconnaissance vehicles. The SdKfz 222, which Richter's crew operated, employed 8mm face-hardened steel plate on the hull sides and rear, with 14mm protecting the front glacis. Face hardening increased surface resistance to penetration, but only by approximately 15 to 20% compared to homogeneous armor of the same thickness. Against M2AP ammunition at typical combat ranges of 300 to 500 meters, this armor provided virtually no protection. The SdKfz 231 series, the six-wheeled armored cars used extensively by German reconnaissance battalions, fared marginally better with 10 millimeters of armor on the hull. But marginal improvement meant little in practice. At 400 meters, a range where crews believed themselves reasonably safe from machine gun fire, M2AP rounds could still achieve reliable penetration. The Wehrmacht's Technical Manual for Armored Reconnaissance, revised in July 1943 after North African experience, included a sobering addendum. American 12.7mm armor-piercing ammunition must be considered capable of defeating all reconnaissance vehicle armor at normal engagement distances. The ubiquity of the M2 in American units compounded the problem. Standard U.S. Army tables of organization and equipment allocated M2 Brownings at multiple levels. An infantry regiment typically fielded 12 to 16 of these weapons in its weapons company and headquarters units. An armored division might deploy over 200 M2s across its tank battalions, armored infantry, and support units. American half-tracks, the M2 and M3 series that transported infantry and towed artillery, commonly mounted a single M2 in a pintle mount above the crew compartment. This proliferation meant that German reconnaissance units couldn't simply avoid known anti-tank positions. The M2 appeared everywhere, on stationary defensive positions, mobile vehicles, and even dismounted from vehicles for temporary emplacement. A German probe into American lines might encounter M2 fire from half a dozen different positions, each capable of inflicting lethal damage on light armor. The weapon's effective range of 1,500 meters against vehicular targets meant that German forces often came under fire before identifying the source. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. German crews attempting to counter M2 positions faced additional challenges. The weapon's sustained rate of fire, approximately 400 to 500 rounds per minute in practice, allowed gunners to walk fire onto target and maintain pressure on moving vehicles. The ammunition feed system, using disintegrating metallic link belts, enabled rapid reloading without the gunner leaving his firing position. American gunners trained to engage light armor using the weapon's iron sights out to 800 meters and telescopic sights for longer ranges. The moment that crystallized the threat came during Operation Husky, the Allied invasion of Sicily in July 1943. Hauptmann Werner Schulze commanded a reconnaissance company of the Hermann Göring Panzer Division, tasked with screening the division's withdrawal from Allied beachheads near Gela. His after-action report, captured by American forces and later archived in the U.S. National Archives, documented what he termed the systematic destruction of German reconnaissance capability by American automatic weapons. On July 11, 1943, Schulze's company consisted of 14 armoured vehicles, 8 SdKfz, 2 31 series armoured cars, 4 SdKfz, 2 51 half-tracks, and 2 captured British Daimler Scout cars. Their mission was to establish observation posts covering Highway 115, the main coastal road running northwest from Gela. The terrain consisted of rolling agricultural land with scattered stone farm buildings, offering reasonable fields of observation but limited concealment for vehicles. Schulze deployed his vehicles in a dispersed screen, maintaining radio contact between positions separated by 800 to 1,000 meters. The expectation was that American forces, still consolidating their beachhead, would probe cautiously northward with infantry supported by light armor. German doctrine called for reconnaissance units to observe, report, and withdraw before contact with superior forces. The 14 vehicles should have been sufficient for this screening mission. American forces appeared at approximately 0900 hours. Rather than the expected infantry formations, Schulze's forward observers reported a column of approximately 30 vehicles, M3 half-tracks, jeeps with mounted weapons, and several M4 Sherman tanks. The column moved with surprising confidence, maintaining formation and speed despite entering terrain where ambush was possible. Schulze ordered his vehicles to fall back to prepared positions, standard procedure when encountering armor. The engagement began when Oberleutnant Karl Hoffmann's SdKfz 231, positioned near a stone farmhouse, attempted to observe the American column from approximately 600 meters distance. Hoffmann later reported hearing the distinctive sound of American heavy machine guns before seeing their effects. The sound was continuous, he wrote in his statement. Not the bursts one expects from machine gun fire, but a sustained hammering that seemed to come from multiple positions simultaneously. The first vehicle destroyed was Feldwebel Otto Klein's half-track, positioned to Hoffmann's right at roughly 500 meters from the American column. Witnesses reported that the vehicle was struck by what appeared to be dozens of rounds in rapid succession. The half-inch projectiles penetrated the hull armor, struck the engine compartment, and ignited fuel lines. The vehicle burned completely within 90 seconds. Klein and 2 crew members escaped. 1 soldier died from wounds sustained during the initial penetration. What shocked German observers was the casual effectiveness of the engagement. The American column hadn't deployed for combat or taken defensive positions. The half-tracks simply stopped on the road. Their vehicle-mounted M2 Brownings traversed toward German positions and began systematic suppression fire. The volume of fire was unprecedented. Schulze estimated that each American half-track was firing between 400 and 500 rounds per minute, creating an almost solid wall of half-inch projectiles sweeping across his defensive line. Hoffman attempted to withdraw his armored car, reversing from his observation position toward dead ground behind the farmhouse. American gunners tracked the movement and concentrated fire on his vehicle. Multiple rounds penetrated the 10mm hull armor. One projectile struck the radio equipment, destroying the unit's ability to communicate. Another round wounded the driver in the shoulder. A third penetrated the fighting compartment and exited through the rear armor, missing Hoffman by centimeters. The armored car limped to safety, but was combat ineffective. Within 15 minutes of initial contact, Schulze's company had lost 5 vehicles, destroyed or disabled, with 11 casualties, including 3 dead. The surviving vehicles withdrew in disorder, abandoning their screening positions entirely. Schulze's report to division headquarters described the engagement with language that revealed profound psychological shock beneath the factual military terminology. The American automatic weapons demonstrated penetration capability against all reconnaissance vehicle armor types at ranges exceeding 500 meters, he wrote. Sustained fire from multiple weapons positions made withdrawal under fire extremely hazardous. Vehicle armor previously considered adequate for reconnaissance operations proved ineffective against American 12.7mm ammunition. The Hermann Göring Panzer Division's intelligence officer, Major Hans Ulrich Rudel, conducted interviews with surviving crew members and examined the destroyed vehicles. His technical assessment, dated July 14, 1943, included detailed measurements of penetration holes and analysis of the ammunition that had caused them. One passage summarized the findings with bureaucratic precision that barely concealed the underlying alarm. Examination of damaged vehicles reveals consistent penetration through 8 to 14mm armor plate at estimated engagement ranges of 400 to 600 meters. Projectile characteristics consistent with American 12.7mm armor-piercing ammunition. Current armored reconnaissance vehicle protection is insufficient against this threat. The material evidence was irrefutable. Rudel's team photographed dozens of penetration holes in the recovered vehicles. The holes were roughly circular, approximately 13mm in diameter, with characteristic deformation patterns indicating hardened steel cores had defeated the face-hardened armor plate. Entry holes showed, punching rather than tearing, evidence of high-velocity impact by projectiles specifically designed for armor penetration. Exit holes, where rounds had passed completely through vehicles, were slightly larger due to spalling and fragmentation of the inner armor surface. What made the evidence particularly disturbing was the concentration of hits on each vehicle. Klein's destroyed half-track had sustained 47 penetrations, far more than necessary to disable it. This suggested that American gunners were either extremely well trained or that the volume of fire was so intense that multiple hits occurred naturally. Either interpretation was troubling. If American crews could place that many rounds on target deliberately, they were far more proficient than German intelligence had assessed. If the hits resulted from volume of fire alone, then American ammunition expenditure vastly exceeded German capabilities. The industrial implications became clear when Rudel examined captured American ammunition stocks. A single American half-track typically carried 1,000 to 1,500 rounds of 12.7mm ammunition for its vehicle-mounted M2. An American infantry regiment might have access to tens of thousands of rounds in immediate supply, with production facilities in the United States capable of manufacturing hundreds of millions of rounds annually. German soldiers, trained to conserve ammunition and make every round count, found the American approach to firepower almost incomprehensible. Schulze's experience was replicated across Sicily during July and August of 1943. The 15th Panzergrenadier Division reported similar encounters with American M2 fire. The 1st Parachute Division, composed of elite Luftwaffe troops, documented cases where M2 positions had destroyed multiple reconnaissance vehicles in single engagements. By August, German tactical radio traffic routinely referenced American heavy MG positions with the same concern previously reserved for anti-tank guns and artillery. The psychological transformation was complete. Weapons that German crews had dismissed as oversized and impractical now dominated the battlefield against light armor. Vehicles that had provided relative security in Poland, France, and North Africa suddenly offered no protection against American firepower. The carefully cultivated confidence in German technical superiority confronted the industrial reality of American mass production. Weapons that were good enough, manufactured in overwhelming quantities, and deployed with a lavishness that German forces couldn't hope to match. The half-inch machine gun had taught German reconnaissance crews that material abundance could overcome tactical sophistication, and that lesson was written in perforated armor and casualty reports across the Mediterranean theater. The lessons learned in Sicily reverberated through German armored reconnaissance units across all theaters by autumn of 1943. Wehrmacht training schools revised their curricula to include specific instruction on American heavy machine gun capabilities. New crews received detailed briefings on the M2 Browning's penetration characteristics, effective ranges, and tactical employment. The weapon that had been dismissed as an oddity 18 months earlier now occupied an entire section in the Armored Reconnaissance Combat Manual, distributed to units in October 1943. German industry attempted to respond with material solutions, but the response revealed the limits of wartime production capacity. Daimler-Benz, manufacturer of the SdKfz 231 series, developed UP-armored variants with 14.5mm frontal armor and 10mm side plates increased to 12mm. These modifications added approximately 400 kilograms to vehicle weight, reducing maximum road speed from 85 to 70 kilometers per hour and severely impacting cross-country mobility. Worse, even this additional armor only marginally improved protection. At close ranges, M2 AP ammunition could still achieve penetration. The fundamental problem was insurmountable. Reconnaissance vehicles required speed and mobility to accomplish their missions. Adding sufficient armor to reliably defeat 12.7mm fire meant increasing weight to the point where vehicles could no longer perform reconnaissance duties effectively. German designers faced an impossible choice: accept vulnerability to American heavy machine guns or sacrifice the mobility that made reconnaissance possible. Most units chose mobility, accepting that encounters with M2 positions would likely prove fatal. Klaus Richter's Reconnaissance Battalion, reconstituted after losses in North Africa, received the UP-armored SdKfz variants in late 1943. His crew's new vehicle offered marginally better protection, but the psychological damage was permanent. "We no longer trusted the armor," Richter recalled in a 1978 interview. "Every mission felt like we were driving thin-skinned trucks that happened to be shaped like armored cars. The Americans had taught us that protection was an illusion, and we never forgot that lesson." The tactical adjustments imposed significant costs on German reconnaissance effectiveness. Pre-war doctrine had emphasized aggressive reconnaissance, pushing close to enemy positions to gather detailed intelligence. After encountering M2 fire in North Africa and Italy, German reconnaissance units adopted much more cautious approaches. Standoff distances increased from 300 meters to 800 meters or more. Direct observation gave way to indirect methods, observing dust clouds, monitoring radio traffic, and relying on aerial reconnaissance when available. This caution reduced the quality and timeliness of intelligence reaching German commanders. During the Normandy campaign, in summer 1944, German reconnaissance units repeatedly failed to provide adequate warning of American movements, in part because crews were reluctant to close within effective observation range when M2-equipped American positions might be present. The 5th Panzer Army's intelligence officer noted in July 1944 that reconnaissance reports had become vague and delayed, directly attributing this degradation to crew concerns about American automatic weapons. The personnel costs were equally significant. Experienced reconnaissance crews, survivors of campaigns in North Africa and Italy, were invaluable assets. Their knowledge of terrain reading, enemy tactics, and survival techniques took months to develop. yet these veterans were being lost at increasing rates to American heavy machine gun fire. Replacement crews lacked both experience and confidence, creating a downward spiral in reconnaissance capability. By 1944, German reconnaissance battalions operated at 60 to 70% of authorized strength, with chronic shortages of experienced personnel. Werner Schulze, whose company had been devastated in Sicily, survived the war but never returned to combat duty after being wounded in Italy in October 1943. His final report before evacuation to Germany assessed American firepower with stark honesty. We cannot compete with their material abundance. Our technical sophistication is meaningless when they can afford to fire 10,000 rounds where we fire 1,000. The 12.7mm machine gun is merely the most visible symbol of this disparity. The production statistics behind the M2 Browning revealed truths about American industrial capacity that German planners had consistently underestimated. Colt's Patent Firearms Manufacturing Company, the primary M2 producer, manufactured over 400,000 weapons at its Hartford, Connecticut facility between 1940 and 1945. Additional production came from other contractors, Buffalo Arms Corporation, Frigidaire division of General Motors, and the Kelsey Hayes Wheel Company, among others. Total wartime production exceeded 2 million weapons, a number that dwarfed German machine gun manufacturing by a factor of 5. But weapons alone didn't tell the complete story. The United States produced approximately 11 billion rounds of 50 caliber ammunition during the war years. 11 billion rounds. German reconnaissance crews who carefully rationed their 7.92mm ammunition, conserving every belt for critical engagements, found themselves facing an enemy that could expend ammunition with what seemed like reckless abandon. American units routinely fired thousands of rounds to suppress a single position, an expenditure that would have been considered criminally wasteful by German standards. The ammunition production was possible because of infrastructure, investments made during the 1930s, and rapidly expanded after 1941. Lake City Army Ammunition Plant in Missouri, which began operations in 1941, could produce 30 million rounds of 50 caliber ammunition monthly by 1943. Similar facilities in Twin Cities, Minnesota, and Denver, Colorado, operated around the clock with 3 shifts of workers. The production lines employed semi-automatic machinery that required minimal skilled labor, allowing rapid training of new workers to replace those entering military service. This industrial model, mass production using interchangeable parts and semi-skilled labor, contradicted German manufacturing philosophy. German weapons production emphasized craftsmanship and precision tolerances. The MG-42, introduced in 1942 as an improved version of the MG-34, was a mechanical masterpiece with a cyclic rate of 1,200 rounds per minute. But it required skilled machinists to manufacture, with tolerances measured in hundredths of a millimeter. Production was limited by the availability of trained workers and specialized machinery. American M2 production used looser tolerances and simpler manufacturing processes. Parts were designed to be interchangeable between weapons without hand-fitting. This allowed production at multiple facilities with consistent quality. More importantly, it enabled field maintenance with standardized parts. A damaged M2 could be repaired by swapping complete assemblies rather than requiring precision machining to fit replacement parts. For an army operating thousands of miles from home factories, this maintainability was as important as initial production. The contrast extended to vehicle mounting systems. American half-tracks used standardized pintle mounts that allowed rapid installation and removal of M2 weapons. The same mount design appeared on jeeps, trucks, tanks, and fixed positions. German vehicles used specialized mounting systems specific to each vehicle type, complicating logistics and limiting tactical flexibility. An American unit could remove an M2 from a disabled half-track and mount it on a jeep within minutes. German crews faced hours of work to transfer weapons between vehicles. German industrial production statistics reveal the structural disadvantage. Total German machine gun production, including all types and models, reached approximately 1.2 million weapons during the entire war. American production of the M2 Browning alone exceeded this by nearly 1 million weapons. When other American machine gun types were included, the disparity grew even larger. Germany, fighting a multi-front war with limited resources and increasing Allied bombing damage, simply couldn't match American industrial output. The bombing campaign against German industry, while often described in terms of strategic targets like oil refineries and aircraft factories, also devastated small arms production. The Grossfuss Company in Döbeln, a major MG-42 manufacturer, suffered repeated bombing raids in 1944. Production fell from approximately 1,500 weapons monthly in early 1944 to fewer than 500 by year's end. No comparable disruption affected American small arms production, safely located thousands of miles from combat zones. The story of German reconnaissance encountering American M2 Browning fire represents more than tactical adjustment to a specific weapon. It encapsulates the fundamental asymmetry that defined the Second World War's material dimension: precision versus abundance, craftsmanship versus mass production, conservation versus expenditure. German soldiers had been trained to believe that superior engineering and tactical sophistication would overcome numerical disadvantages. The 12.7mm machine gun that could penetrate armor at 500 yards demonstrated that industrial capacity, when applied with competent design, could neutralize tactical advantages. Klaus Richter survived the war and eventually settled in Bavaria, where he worked as an automotive mechanic until retirement. In interviews conducted during the 1970s and 80s, he returned repeatedly to his experiences with American firepower. "We were taught that German weapons were the best in the world," he reflected. "The MG-42, the 88mm cannon, the Panther tank, all technical marvels. And they were. They needed weapons that worked well enough, and they built millions of them. That was something our generals never understood until it was too late." The M2 Browning remained in American military service long after the war ended. It saw combat in Korea, Vietnam, Desert Storm, Iraq, and Afghanistan. The basic design, created in 1918, proved so robust and effective that successive generations of American soldiers used weapons that would have been familiar to their grandfathers. By the 21st century, M2s, manufactured in 1943, were still in inventory, maintained and rebuilt but fundamentally unchanged. Few weapons systems in history have demonstrated such longevity. For German veterans, the weapon became a symbol of lessons learned through painful experience. Post-war memoirs and unit histories frequently reference encounters with American heavy machine guns as turning points in tactical understanding. These accounts describe not just the physical threat, but the psychological impact of realizing that assumptions about American military capability were fundamentally flawed. The same industrial system that produced refrigerators and automobiles in peacetime could produce weapons of remarkable effectiveness in quantities that German industry couldn't approach. The technical specifications that made the M2 effective against German light armor, the 12.7mm cartridge with its armor-piercing variant, the sustained rate of fire, the long effective range, were not secrets. German intelligence had access to this information throughout the war. What German planners failed to grasp was the operational significance of having these weapons deployed in enormous numbers across American units. A capable weapon becomes transformative when it appears everywhere, when ammunition is abundant, and when crews are trained to employ it aggressively. The photographs of damaged German reconnaissance vehicles, archived in military museums and historical collections, show the material reality that no amount of tactical sophistication could overcome. Neat circular holes through armor plate, spalling damage on interior surfaces, penetrations at angles that indicated hits from hundreds of meters away. These vehicles weren't defeated by technological marvels or exotic weapons. They were defeated by a machine gun designed in 1918, produced by the faith, millions, and fired by soldiers who'd been trained for weeks rather than years. That morning in Tunisia, when Klaus Richter first saw sunlight streaming through a hole in his armored car's hull, marked more than a tactical revelation. It marked the moment when the material reality of American industrial power became undeniable, when German confidence in technical superiority confronted the simple truth that quantity has a quality all its own. The half-inch machine gun that penetrated 25 millimeters of armor at 500 yards wasn't just a weapon. It was proof that the war's outcome had been determined by factory floors in Detroit and Hartford long before soldiers encountered each other in the deserts of North Africa. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.